Good evening, students. I am going to discuss Rutherford alpha particle scattering experiment. Okay. You know, after discovery of electrons, protons, and neutrons, it becomes clear that atoms is made of electrons, protons, and neutrons. These three very stable subatomic particles. Okay. There are some subatomic particles like deuterium, meson. These are unstable subatomic particles. But electrons, protons, and neutrons are very stable subatomic particles. But in an atom, what is the position of electrons? What is the position of neutron? What is the position of proton? Before the experiment of Rutherford, people know this. Okay. The Rutherford conducted this experiment. He took a lead block. This is the lead block. This is the lead block. This is the lead block. Okay. And he took a very thin gold foil, 0.0004 millimeter breadth. And in the lead block, he took a radioactive substance as the source of alpha particles. Okay. Alpha particles, which has alpha particles which has plus 2 unit positive charge and mass 4 unit. Mass 4 unit. This charge plus 2 unit and mass 4 unit. Okay. So Rutherford conducted this experiment by the bombarding a thin sheet of gold foil with alpha particles. Then start is. In this experiment, Rutherford directed high energy stream of alpha particle from a radioactive source in a thin sheet of 0.0004 millimeter thickness. Okay. In order to study the deflection caused by the alpha particle, he placed a fluorescent zinc sulfide screen. This is the zinc sulfide screen. Okay. Rutherford made certain observation that he observed that a measure of, look at the experiment, a measure fraction of alpha particles bombarded towards the gold sheet passes through it without any reflection. But okay, the first he observed that a major fraction of alpha particle bombarded to the gold sheet passes through it. It without any reflection, and he decided most of the space of the atom is empty. Okay, you see that some of the alpha particles are deflected with a some angle. Look at this, some angle. What is the reason? Alpha particle has 2 unit positive charge. But that is decided that atoms have a place with positive charge. 2 positive charge repel to each other. Okay. The positive charge in an atom is concentrated in very small volume. He decided that. Very few, one alpha particle out of 20,000 alpha particles. Very few alpha particles are deflected back. That is only a few particles, hardly one particle out of 20,000. Okay. So he decided that volume of volume of atoms, most of the volume of the atoms occupied by the charge, but positively charged particle in a very small, okay, volume occupied by the positively charged particle in very small place, very small place. By this experiment, Rutherford made his atomic model. The positively charged particles and the most of the mass of an atom concentrated in a few place, and in a place of the in the middle of the place is called nucleus. Okay, he called nucleus. First, atoms. The atoms there is atoms two part. One is nucleus and other is electrons. The nucleus, what is nucleus? The positively charged particles and most of the mass of an atom was concentrated in an extremely small volume. We call the region. This region is the nucleus of the atom. Okay. Rutherford model proposed that the negatively charged particle, that is, this is the electrons. Sorry. This is the nucleus. Rutherford proposed that negatively charged electrons surrounded the nucleus of an atom. He also claimed that electrons surrounded the nucleus revolve around in high speed with a circular path. The circular path, the electron move করে with high speed. ঠিক আছে? He named this path as a orbit. Of course, orbit is circular. Lastly, electrons being negatively charged and nucleus being densely concentrated positive charge. So particles are electron negatively charged and nucleus positively charged. Proton are there and neutrons are there. They have some Coulombic force of attraction. Okay. Okay, thank you. I will discuss next day.